is going to be the first video covering section 6.4 and 6.5 notes. So you'll see a lot of these green boxes. That is for you to fill in to give yourself hints on what I do to solve the equations. There's nothing I'm going to fill in for those. So part 1, basic equations. So example 1, solve the following equations. So when you only have one exponential or one logarithmic expression with the variable in it, these equations are as simple as just getting the variable by itself. So for part A, I'm going to divide by 1,000. Now here, because I want to get rid of the 3 next, this is where we're going to take log base 3 of both sides, because that will cancel out the 3 on the right hand side. Then log base 3 of 9 is 3 to what power equals 9? Well, that's 2. And then we get negative 0.1t. I'm going to multiply both sides by negative 10. Negative 20 equals t. Then remember, you can always check your work by plugging it back in. For exponential equations, it's not necessary, but we will see for logarithmic equations, that last step will be necessary. But for part A, I am going to skip it for now. Now for part B, there is still only one exponential expression, and it's the only expression that contains a variable. The first thing I'm going to do, because I don't really like that fraction, is multiply by the denominator. Whatever you do to one side, you have to do to the other. So then we get 1 plus 3e negative 2t times 75 equals 100. We can divide by 75. Get 1 plus 3e negative 2t. And that will be 4/3. Subtract 1, subtract 1. 3e negative 2t. 4/3 minus 1 is 1/3. Now I want to cancel out that 3. Because I have a fraction on the other side, instead of dividing by 3, I'm going to multiply by 1/3. So we get e negative 2t equals 1/9. Take the natural log of both sides. Now the reason why I'm using natural log instead of log base 3 like in the last one is because the base of the exponential is e, not 3. So the ln and e cancel out, so we get negative 2t equals, and I can't really calculate what ln of 1/9 is, but that is the same thing as ln to the 9 to the negative 1 power. Divide by negative 2, divide by negative 2. Then using log properties, we can drop that negative 1 down. Over negative 2. But then the negatives cancel out, so we are left with t equals ln of 9 over 2. That is our final answer. You can plug it back in to check if you want to. Now for C, again, I have one log expression, and it's the only expression that contains a variable. So I'm going to subtract 5 from both sides. Divide by that negative 7. And just like in parts A and B, how to cancel out the exponential, I took a log. To cancel out a log, I'm going to exponentiate. So I'm going to 8 it up. 8 it up. So that's not times 8, but 8 to the power of. Well, the 8 to the power of log base 8 will cancel out, so we're left with x plus 2. Then 8 to the negative 2 power is 1 over 8 squared. Subtract 2 from both sides. We get x equals 1 over 64 minus 2. So x equals negative 127 over 64. And now for part D. Subtract 2, subtract 2. Don't forget, when you subtract the 2, it only cancels out the 2, not the negative sign in front of the log. So we'd have to divide by that negative 1 to get rid of that negative sign, or multiply by negative 1, whichever you prefer. Now, the base here, remember, if it's not written, it's assumed to be 10. So I'm going to 10 it up on both sides. So this gets t minus 3 equals, now again, the answer comes out the same, but I do want to make a point. This is not 10 times 1. It's 10 to the first power, which is 10. Add 3, t equals 13. So that is how you can solve basic equations with exponentials and logarithms.